This Hangout is live. Welcome, VJuggers, to 20th, maybe 19th session. Today joining me is Colin Vipurs. Hey, Colin, how you doing?
Hey man, all good here. How are you?
Very, very well, thank you. So Colin and I are both in London. Well, I'm just outside London. Oliver, how you doing from Prague?
I am very well, gentlemen. It's great to be here this evening.
Awesome. So first of all, I'm gonna just start by quickly sharing my screen. Screen share. And I just wanted to show you first a bit of recursion, and then my email, and now the virtual jug. So we're going to go to future sessions. I've put up a couple of future sessions just today. One on opinionated Java FX from the much acclaimed Mr. Adam Bean. And that is on Wednesday the 27th of August. So from future sessions, you can RSVP here, and that'll RSVP directly through the Meetup site. You can also add it to your Google Calendar or grab an iCal if you prefer. And also pragmatic functional refactoring with Java 8, and this is from a couple of guys from London as well, which I'm sure Colin knows, Richard and Raoul from the LJC. And again, you can RSVP through the site.
Simon, is Adam Bean the guy who keeps winning all those cool awards for being awesome and gets very embarrassed every time his talents are brought to the attention of the public?
Yeah, he's like the Java rockstar, Java champion, Java acclaim, insert acclamation here kind of guy. So,
Humble, yeah.
Yeah, absolutely, absolutely. No, he's cool. He's a really cool guy.
Adam's a great guy.
He is. But for now, you need to go to the live session card. From here, click the play button, or otherwise you'll just be sitting there watching this. Log into RC, and we'll have some discussion. If you have any questions to talk to pose to Colin, add them through IRC, and we'll ask Colin at the end. But feel free to also stick a bunch of comments in there. Please do share on Twitter, Facebook, Google Plus, or LinkedIn, just to make our community bigger. But for now, I'm going to find Chrome again. Whoa, a bit of recursion. I'm going to unshare, and I will pass over to Colin. Colin, who's going to talk to us today about everything, all the problems that you guys found in Shazam, and what you're doing now to overcome those problems. Is that fair, Colin?
It's probably close enough.
That's close enough.
Well, it depends how drunk I get throughout the sessions.
Awesome. Cool. Over to you.
Awesome. Thank you. So, hi everyone. So I guess probably not a lot of people know who I am. So I'm going to go to the Ping Mohawk, get drunk a lot, and rant about testing an awful lot. And I am currently the embarrassingly titled Senior Technology Evangelist at Shazam, which basically means I spend a lot of time actually doing things like this and ranting at people and being the technical face. And my real job is actually ensuring, as development teams, we do things the right way and do things nicely and make sure everything's well tested. So I'll give you a little bit of background about myself before we start. So I've been a professional developer, well, I say professional as inverted commas on that one, developer for about 16 years now. My first job was in 1998, and probably about 2 months into that job is when I released my first bug production. Very, very embarrassed, quite mortified. And at the time what we did was we used to have an engine, we called it, very descriptive name, that would take raw TV listings data and translate that according to an in-house language for lots of different customers. So if you've ever read a TV listing, like online, in a magazine, in a newspaper, there's a good chance it's been through quite a lot of my software. So I had to make a really small change for about 2 customers, which I made, pushed it out to production, and for the rest of the day made that change for every single person. So what I did was go back, write a simple Perl script that would basically iterate over every one of our customers and all our data for the last 2 weeks, and very naively just diff outputs. But at the end of a test run, which took about 5 hours, you got a nice little diff output. You could go verify it, and you'd know whether what you'd done had basically broken anything. I had little knowledge at the time of the terms acceptance testing or regression testing, system testing, anything. This was just basically my own sanity. Don't ever release bugs again. And I suspect that software's still running today, actually. But the key thing was never any production bugs released by me ever again, at least on that piece of software. So in, say, about 2000, 2001, I got into Java, carried on being test obsessed there, and picked up unit testing. So not a lot of people were doing this at the time. This is kind of times when XP was becoming a thing. There was one unit testing book. I think it was the JUnit cookbook by J.B. Rainsberger. So we didn't really have good practices. None of us really knew what we were doing. But that's stayed through me my entire career up till 2010, which when I started work at Shazam. And basically I got hired there to rewrite our entire backend system. So I'm going to screen share with you now and drop onto my lovely PowerPoint presentation when I can find the buttons. This technology confuses me quite a lot. Right, hopefully now everyone should be able to see my opening slide.
Yeah, we can see that.
This presentation is normally done with somebody else, but he's slacking it off in Greece at the moment. But I'm going to go join him on Friday, so that's okay. So, I'm hired to rewrite our system. That's quite a big undertaking for any company, but I think this picture pretty much sums up why. So that's essentially what it was like working on our system. 10 years old, really horrible, messy code. It was J2EE, but it wasn't horrible just because it was J2EE. I think the worst offending thing was a 3,000-line JSP class. So we never got any work done. Like, trying to change anything took forever. We had no automated tests. We had no CI. The whole thing was a mess. And the key thing was deploying the software was a bit of a nightmare. So we had a schedule which was every week on a Tuesday morning, maintenance window between 10 and 12. So what we do is deploy. It would take a lot longer than that maintenance window allowed. Inevitably something was wrong. We'd roll back, we'd patch it on Wednesday, we'd roll out again Thursday. So every week in less than 2 hours turned into probably more like once a fortnight, and it took 3 days. So this is kind of like the backstory of why we decided to do a rewrite. Sorry, I'm just going to drink. So I've got this awesome greenfield project to do, and I can basically do whatever I want. I'm running the team. This is awesome. We can test absolutely everything. So the first thing I decided to do is basically pick my BDD tool. Now, to be fair, that's probably not the first thing I should have been doing, but I was a lot younger then and quite excited. And we picked JBehave. So I think at the time, the choices came down to basically JBehave or Cucumber were the two front runners. Cucumber didn't have Java support. I don't particularly like Ruby, to be fair. We didn't want to learn Ruby. We were a team of Java developers, so we picked JBehave. Now, JBehave, for anyone who knows Cucumber, it's basically the same thing. Is I write my stories in a text file like this, and what I do is I've got some code in the background that just maps these text files to code. So this is basically a dead simple story. So just given I'm a user, and when I start up, I tag imports by TDD, then I receive the expected track. I kind of guess at this point there might be some people who don't know what Shazam does. So quick thing basically is you're in a club, you're in a pub, you're in your car, listen to radio, whatever, you like a song, you don't know what it is. It's that magic little app where you get out your phone, push the button, and it comes back and tells you you've got really, really terrible taste in music. In fact, Simon doesn't know this, but I actually go and look at his account, see what he's tagging. It is some terrible stuff.
I'd agree with that.
Lots of Justin Bieber in there.
Bieber for forever. He's got a tattoo on his chest.
So this is where we're at for writing our top level stories. So, you know, the whole point of BDD is like your product owner can read it, BAs can own it, anybody can read these and understand what's going on. Like, just reading this now is you should be able to read this and understand what we're going on. It's just, does our basic flow actually work? So this is like a really simple diagram of our architecture. So this is a phone. This is our really old, horrible, monolithic J2E system, and this is our shiny new system. So two things we have about our new system: it's got to scale. So scale in terms of performance, so latency, throughput. We want it to scale horizontally, and it needs to scale in terms of development. So we had 4 guys on the team at the time, but we were planning for when we've got 10 guys, 20 guys, 50 guys. So we go with a microservice architecture, although I'm not sure that term existed at the time. We just called it SOA. So we've got a whole bunch of really small systems that you can test in isolation. So this test is basically pretending to be a phone. So it runs from here. Doesn't matter what the entry point to the system is, it just guarantees correctness. And that's kind of good, so I'm not going to really talk about them so much. We still do them now as they are. We're really, really happy with them. But we want to test these little systems here. Now, the test audience for those is not product people or BA people, it's developers. We're just basically using BDD frameworks to acceptance test the system, but purely for us. So the nice thing about that is we don't have to worry about it being really descriptive and nice. We can work on a developer level. So the first system we did was rewriting our search engine. So dead simple, well, not that simple. Simple enough system, you know, just feed in our data, type in some search queries, give you a result back. I'll show you an example, but it's not actually on our website anymore. It's kind of sad. So this is the kind of test we write. So again, we're all developers. This should be dead easy to read. So given I've got these artists to search, we basically, at this point, we hijacked cucumber style, or sorry, gherkin examples tables. So we'd load in an artist. I do a get call, just HTTP get. I call an endpoint, and I get some JSON back. Awesome, yes? Brilliant. We can all read that. We're all clever. We understand URLs. We understand JSON. This is actually really, really useful. And because it's just typical verbs like when I get a URL, when I receive JSON, this stuff is really reusable across all of our systems. In fact, there's a BDD framework for PHP called Bhat, and that has a little framework you can plug in called Mink. And that basically does exactly the same thing. It gives you access to all kinds of HTTP constructs so you can just build up your language. So this is really, really cool, except it's not. So we've got, this is testing our system really nice. Actually, let me move on to something else first. So this tests our search system. Now, if you see this diagram here, so say, for example, this is our search system. We have other systems that call that. And those systems we also want to test in isolation. So we don't want them calling our real search service, because that's subject to normal rules of randomness. But, you know, for this test, I'm basically checking, I'm looking for the Soho Cobras. The ID may be different. If I issue the request, it's probably going to bring back more results than this. So we want to test that service in isolation. I had a diagram, but I've lost it. Oh, okay. No, not in this copy of the thing. So it's kind of like, it's fractal. I like to think of these testing things as being fractal in nature. So unit tests, everybody knows how to use mocking frameworks to isolate units, which is mostly a good thing. But this does the same thing, but now at a system level. So we take an entire deployable WAR file and we isolate all of its dependencies with fakes as well. And you can actually take this all the way up to the complete boundaries of your system, only replacing the bits you need to replace. Facebook looking at you here. So what we do is, so this is an example of code that is, say it's service X that calls search service. So what this one would do is say, given the search service is up, So this would actually go off and spin up a remote HTTP server, but that we can actually control programmatically. By itself, does nothing, just returns a 404. Then we say the search service handles GET requests to this endpoint. So what we do at this moment is we fire off to this server and say, you're going to accept a GET request on this URL. And when you do, we want you to respond with this JSON. So fully programmatic server at runtime. So what we do is, so this service, the test for this, they would spin up this remote service, pretends to be this, and control the output, which is exactly the same way you do this with a mock. So it really should be really easy to understand the concept there, and it seems like the right thing to do because we're just doing what we do at the unit level, just at a higher level. Now, this started, so we did this for quite a few months, but soon realized it was going to be a bit of a problem. So the thing about JSON is it's all very nice here because we can read it, but when we get any kind of API change or structure change, all of a sudden a whole bunch of tests break. In fact, let me just show you a quick. So here's an example of some of the tests we had for search. So there's a lot of test data preparation there. There's a lot of tests coming in here. So you can see all these ones here. We've got a bunch more in here. A lot more here. So you're going to get the idea is there's a lot of tests going on. So any kind of change basically meant is we would have to go and change it in the search service first. And that meant changing the expectations for, quite frankly, a shitload of tests. But not only that, any service that cold search and set up this JSON expectation as well, they also had to change. So if I want to do something silly like just add in an extra field on here, all of a sudden I've got 50 to 100 tests all failing for something that's a really, really simple change, which kind of sucks because it means we're spending a huge amount of time maintaining tests. And that's not helping us move faster on our delivery. It's kind of the reason we do so much testing is we want to make a change, move fast, get into production. This is kind of having the inverse effect now, so we needed to make a change. The one thing we really did like is we can control the outside services, so we can still keep faking those and control what they do. So we moved on to, oh, that's the slide. Ignore that one now. I've got no, forget it. Anyway, so we decided to do this. So now we're basically doing a very similar thing, but we're saying given the search service is up, so we still spin up our fake server. But now we change the language a little bit to say the search service handles artist search requests to, and we've got another table. And the service responds with the results. So in the background, what we're doing here is we're essentially translating these examples tables into the JSON representations and the URLs that they need. But it now becomes very flexible because the step story files that JBehave uses, these are now actually owned by the search service itself. So it exposes a test jar that any project can import and just get access to these steps. So this is really, really good. So it means we make a change to a structure, we change it inside the search service itself. All we do is we upload that artifact, well, it happens automatically, it goes into Maven, and services now just recompile everything so it's working as possible. This is really, really, really cool. We really like this. And the nice thing is we've removed all the duplication. Like, I really, really hate duplication. In fact, I hate it that much, it's worth saying it twice. I really, really hate duplication. So we did a bit of a score for this one. Now, we were all very, very happy with this at the time, but we had Steve Freeman come in. Those who don't know Steve, him and Nat Price are the guys who wrote JMock, and they wrote Hamcrest, and they wrote the Growing Object-Oriented Software book, which if you haven't read, you should read. It is the testing Bible. Steve wanted to come in and basically just have a look at what we were up to, and he was just being nosy and was interested in what we're doing. And Steve thought what we were doing was quite insane, because what he's saying is basically we spend a lot of time mapping between text and code. And I only had one thing to say to Steve. Steve, you're wrong. This is really flexible stuff. It's what people are doing. It's BDD. It's cool. It's doing all this GWT stuff. The industry's moving in this way, and we liked it. Of course, Steve wasn't wrong. I was wrong, because this is actually a bad thing. Some of the problems you've got from doing this are navigation between stories and code is really, really difficult. So I think there was a time there was a plugin for Eclipse, so you could basically pick a step and step through to the code. It was really, really slow. A lot of the time, it didn't work very well. So when you were trying to find out what's going on, you're having to basically grab the text, then do a text search within the code to find out the step that's actually executing it. And for some of the steps is, like, you can't see it from here, is like, this is a regex here, and this is a regex. So it might find a step that matches, but not necessarily the right one. And because they're regexes, sometimes JBehave wouldn't even find the right step to import, and we were at the mercy of JBehave and Spring on whichever order things got injected into and which one it picked up first, which led to horrible, flaky test scenarios of, let's just run it again and see if it works this time, which is never a good thing. So this was a bit of an issue. Oh, and some of the things with the regex is what we ended up doing was butchering the language we wanted to use just to make JBehave work properly. That probably sounds like I'm railing on JBehave quite a lot. I'm not. I still think it's a really, really awesome product, but we were using it wrong. So we kind of, I think it took us about 6 months actually before we realized Steve was right. So we decided to dump story files completely and let's just write tests in code. Hey, we all know how to write code, yeah? It's just JUnit. So we just write our tests as we see fit. So, we just go to writing the tests in code. That's it, which is awesome. Now we get to reuse a lot of previous code because the story files just map steps to execution. And then we find straight away is really, really hard things become easy. So this stuff about mapping files into beans and then converting them into JSON, that just goes away now because we're working in code. We can just do it directly. And what we ended up doing with it is things like this just disappeared because we've used something like, we'd create a bean called Soho Cobras, and it would live inside a common package, and it just had all the information in there we needed. But one thing we didn't do is go back and modify our existing tests. So they're working. We may not change these services ever in future. The ROI for retrofitting is not worth it in the slightest. So we're using Java, and we all love Java. Well, probably, we wouldn't be watching this presentation if we didn't. And Java's awesome, isn't it? Not all the time. So the problem with writing tests in code is, well, it's the usual problem with writing tests in code is you can just write code. Story files are awesome because they generally push you towards behavior, not implementation. So there is a mountain of really, really bad unit tests out there. I have another presentation where I rail on this quite a lot, that you cannot understand what they're trying to do. And this is the road we ended up going down as well, because now we can write in code, we just will. So we drop using give and when then syntax completely, because we're just writing code. We lose the abstraction of, the story files here, like we knew they are issuing search requests, but the fact that it's via HTTP has disappeared completely. The URL has disappeared. The JSON format's disappeared. But in code, that started to leak back in again because it's the easiest thing to do. And another thing to do is essentially we started using mocks again. And mocks is not something I think you should ever be using at this level of testing, but I'm going to get onto that later. And the usual problem is we started copying and pasting code around. Some of that to do with the fact we're using mocks and parameterizing that stuff's really hard. Other thing was just we wanted some parameterized tests, but JUnit wouldn't work quite the way we wanted to. So it's just copy and paste hell. So this is essentially where I am right now, is our text file problems have disappeared. That's great, but all we've essentially done is now replaced it with code level problems instead. And we're still spending way too much time maintaining tests. Now, one thing there is our system is fully tested. Like, you could check out any one of our services, run Maven, clean, verify on it. Within a minute or two, it would basically tell you, yes, this stuff is green, it's all good to go. In fact, I think our record at the time for our entire system was 17 minutes from commit to being in a staging environment, which is attached to production databases receiving real traffic. So our ability to deploy code and get it out there is good, and our confidence in our code is really high. So we essentially have, by this point, we have no manual QA. So every developer knows is when I commit, that is going to production, and it's going to our full production system sometime in the next 24 hours. I just don't know when. But the only problem we have is getting to that point is really costly. So this is the point in the presentation where I normally hand over to Savas, who's one of our Android devs. And there's a picture of Android for some reason. And he talks about Android, so I'm going to attempt to waffle my way through this a little bit. So these guys were basically doing the same thing that we were doing. They're trying to do BDD, they want as much automation as possible, but they don't have any JBehave support, any Cucumber support. They have literally nothing. In fact, it's kind of sad for those guys is they're still using JUnit 3, which is just horrendous. So they have to come up with their own mechanism for doing stuff. He has a picture of spaghetti. Not sure why that's there. But basically their tests ended up the same way that our tests were going. It's just horrible implementation-specific code. So here's an example here of a typical test. This isn't from their actual code base. He wouldn't share that. But basically it's can you figure out what this is doing? So let me walk through it quickly. So we're firing up some instrumentation, which is an Android thing. We're firing up some context, which I guess is some other Android thing. We're getting a directory. We're creating a couple of temp files. Yep, all very nice. We're creating an intent, which is another Android thing for launching activities, I think, on Android. I'm not an Android dev. We're setting some data. We're adding some flags. We're starting the activity. We're creating Solo, which I believe is some way to interact with Android for testing. We're looking for some text, looking for some other text, and then we're failing the test if we didn't find it. So I suspect this is very typical for most people doing this level of testing. It's all focused on the implementation, not the behavior. Yeah, so it's unmaintainable. Generally, you come along and figure out what it's doing. So at this point, I think in their life cycle is they were doing a major redesign of their app. We appear to do lots of redesign and rewrites quite a lot. So I think this is, in our application, you can see what your friends are tagging. So this is what our feed used to look like, and this is what it looked like when we put this presentation together, but not what it looks like anymore. But these Android guys decided this is a really good time to basically come up with a better way of testing and rewrite their stuff. So Savas wrote this little library called Gwen, which is basically consists of 3 methods, and this is it. So this is now really easy to understand, and it's given when then syntax. So now I'm going to feel silly actually reading this out to you because it should be obvious. Is given I've got a directory that contains some files, when the user is viewing the directory, then the user can see these files. Now anybody can understand this. In fact, if you think all the way back to my first slide, this is essentially what we're doing at our system level. It's human readable testing stuff. There's a specification, not an implementation. And how this works under the hood is essentially these objects, like directory and user, they are what we call actors inside our system. They know how to do things. So when the given directory contains some files, which is just a constant at the top of the test, is that knows I'm going to go and find the directory I'm going to write some files into. I'm going to write these 2 files out for you and just put them there. It's not important for this part of the test. When the user is viewing the directory, this is all the stuff with instrumentation, intents, activities, actually launching everything. And can see is an assertion, which is just the solo part of checking. So if you go back to here, it's basically, what was the first bit? Contain some files. So contain some files, this is essentially just this bit at the top. This is the can see, the user's viewing, and this is just the can see part. So it's doing exactly the same stuff, but now it's really understandable. And it's fantastically reusable, because anytime I want to create some files or view some files, I can see the files. I just use my user object, and because it's code, I've got the benefit of code complete. So I can just say then user dot command space, these are all the options I can see. Definitely one of the big things story files can't give you is the knowledge of your grammar and your syntax. You generally have to document that elsewhere, look at existing tests, or scan your way through the story files to find out what you can and can't do. But hey, well, Deb's right. So doing command space, that's a really good way of doing method discovery. So he says this came in really useful when they did a change. So on one version of the application, you had to press this little button here to refresh the feed. Because we want everything to look like iOS, we changed this to pull down and it'll do a refresh. So for all of their tests, all they basically had to do was pumping 2 different actions now. So they changed their press refresh button action to pull to refresh action, which was just another one of these intent thingies. Sorry, I don't really get it. And that's it. Now all the tests that interact with this suddenly carry on working, which is pretty damn awesome. So these guys have been doing this for a while, and because I'm really nosy, I like to walk around our office quite a lot and just look over people's shoulders and see what they're doing. So he showed me this, and to be honest, I was really impressed. It was bing, light bulb moment for me. He's got really clean behavior. His entire library at the time was only 8 lines of code. But what it really did was made me change the way I think about testing. And for that, I give the guy a lot of credit, because it takes quite a lot for me to change the way I think about stuff. But I had the realization then is, in our tests, we've been spending way too much time thinking about implementation and not thinking about the behavior. So I took his library back to my desk and basically looked at one of my search tests and rewrote them, and it became this. Now this, again, should be dead simple for someone to read. I've got a search service, so we're a backend team. We still talk about services and clients. That is our language. We don't talk about users and devices and things. We talk about services and clients. So we just say, given the search service has ingested this. Now this is just one of our reusable test beans. When the client searches for Soho Cobras, then the client receives Soho Cobras. So exactly the same way that Android did is, this is an actor, this is an actor. I can control space, command space, whatever, onto this and see what I can do. So I can ingest a bean into our system. I can search for it, and I can see what the results coming back were. So this is all implemented in base classes, which is, that was a bit of a shocking moment for me, because I very much hate inheritance completely. But this seemed like one of those rare cases it's actually useful for. So this is a base class, gives me access to my actors and lets me act upon them. So these are now specifications again. It's awesome. And one of the great things about having then syntax in here is we can no longer use mocks. Because if we want to use mocks, we have to start writing them directly in the tests. And one of the guidelines I essentially put in place is, with inside an actual test, this is all you should see. There should be no other code going on. Perhaps instantiating a bean if you want to reuse it, but there's certainly nothing about mocking frameworks or HTTP. There's no real what looks like normal code. And the really sad thing is the first test I showed you with the story file text that just, let's lip back to it really quickly. Ooh, it's quite a lot. So this one, this is here, is we had this right at this level, but for some reason that message got lost along the way until we started doing this, which is essentially the same thing. So that is the pre-prepared part of the presentation. Believe it or not, it was actually the polished bit. The rest of it is kind of where we took it on from here, and is going to be a bit more shoddy. So we're in this really nice place where this is all really good. But one problem we've got is tests take time to run. So this is essentially the anatomy of one of our tests. So we were using Spring, and what we've got is we're firing up a test. So we have to launch our production Spring configuration. Then we have to have our test Spring configuration that overrides the wiring that we don't want anymore. We're launching Jetty because this is a HTTP test. And we're launching Jersey inside Jetty, which is taking the wiring from Spring and wiring it all together. And my God, this stuff takes a long time. So an individual acceptance test here is taking 9 seconds, which to me feels like a lifetime. And I guess anyone who's doing any J2EE using app servers is, you guys are going to be familiar with all this stuff you're bringing into tests. I see it on Stack Overflow all the time. So I did a quick query yesterday. If you search on Stack Overflow for test and Spring, there's over 20,000 questions, and it's all comically for me because I'm very anal about the use of languages. How do I unit test blah with Spring? How do I get Spring to do this with tests? I'm going to give you a quick tip is stop using Spring in your tests, but we'll get on to this. So running your test from the IDE has a real impact on productivity. So I'm coming in, I'm making a change, I'm pressing Control-R to run my tests, I've sit and twiddled my thumbs. It is the epitome of the XKCD comic about compiling. But I don't really like that. So, if anyone's aware, this is Cohn's pyramid of testing, which, if you've ever seen an Uncle Bob presentation, he always likes to drag this one out, but he also has at the top exploratory testing. And Uncle Bob always states is you want more testing at the lower level and less testing at the higher level. Testing at the high level is slower and it's more brittle. And generally what people think about at the UI level is this. It's a web page. I'm interacting with the web, I'm using Selenium, and I don't want to do that because it's always slow, it's always flaky. The async nature of everything just makes shit crap out all the time. But this is not the only UI. Like Perl is a UI. Interacting with a RESTful service, that is essentially an interface. It's a user interface. It doesn't matter that my users are developers. It's still an interface for those guys to use. So I started questioning, why are we writing so many tests via the HTTP level? Because Uncle Bob states is drive the minimum amount of tests through the UI, drop down a level, start testing at that level instead. So why are we doing this? So you look at this is one of our tests and what we bring up. It's very similar to the diagram. But you're basically looking at is, we're writing an acceptance test. So the search system, we want to test searches. We're coming in via HTTP. It's going in to the Jersey layer. It's hitting our domain logic, and it's hitting some backend systems. So it's hitting databases, it's hitting messaging systems, it's hitting any kind of remote system that we need. It's bringing in Spring, and it's bringing in whatever kind of configuration we've got going on. So I guess the guys doing J2E stuff is, You know, this is hitting your JSPs, it's hitting your controllers. If you're doing it with Play, it's hitting your Play framework, it's going through your MVC layer, it's doing all this stuff all the time. But that shit is really, really slow and time-consuming, and it's really bad. This is essentially the bit all we really care about. I care about my domain logic a lot of the time. Is, you know, once I've sent one request through HTTP, you know what? I know my HTTP layer works. Once I've done one thing that goes off, and so we use DynamoDB quite a lot. Once I've written something to DynamoDB, I know that works. I don't need to test that 50 times. And especially since for us is like we have an abstraction over Dynamo, we have an abstraction over SQS, we've got an abstraction over our HTTP stuff, and these sit in common libraries somewhere. So we've already tested them as part of their own package, and we're bringing them out into multiple services and testing them again. This is probably some of the most tested code ever written. It's battle-hardened in its own project, and even further hardened elsewhere. So why do we keep doing it? So, I have a quick digression here about how we decided to change what we're doing. So, I think this was some point last year, me and one of my colleagues decided to start looking at our code. Because one of the problems we were facing was our developers were complaining it's hard to follow our business logic. And I putting this down essentially to, I'm not blaming Spring for this in its entirety, but it definitely contributes, is we were in essentially dependency injection hell, which I've seen a lot of people doing. So, you know, Spring documentation states you should just inject all your dependencies. We're doing unit testing with mocking, so we inject every single dependency we possibly can to control the system, yeah? Loads of people do this. So what you end up with is your entire system wired through Spring. So what you end up with is huge call graphs going down. Well, that's not really what you want to be doing. That's not only going to be really hard to understand stack traces, but it's really hard to follow your code, and because you're mocking using interfaces. So what we found ourselves doing was, at the entry point into our system, so inside here, to find out what's going on, we have to jump into Spring to find out what's going on. Then we have to find the right implementation of the interface so we can jump back, go down a level. Now it's still an interface, it's injected, so back to Spring again. And we're sat spending a lot of time bouncing back and forth between the boundaries of our system to find out what the logic was. So we didn't want to do this anymore. So we decided to just take a completely different approach. We were abandoning Spring. We were going to start newing objects in different places. And just started again, really. So the example we're using for it was essentially, it's one of our microservices called the recognition service. Now, what this essentially does is it receives what is pretty much the audio from your phone, sends it in via HTTP with a whole bunch of logic inside here that responds to results from clusters. A bit of an overloaded term, I know. But what we essentially have is what we call a cluster. And the cluster is responsible for taking the audio and sending back what it thinks are possible matches, which, without giving too many things away, especially think of it as just like a track ID and some other bits of information. And what we do is we hit a whole bunch of these in parallel. They come back with all kinds of results, and we have a whole bunch of logic inside here which decides what track you as a user are going to see. So one of the things about these guys is this is all driven through configuration. So our DevOps guys can basically go in, modify a config file. They can change the ordering at which we hit the clusters. They can change the endpoints. We have several different types of clusters. So anyone who knows that you can tag TV with our app is, one of these would be like a TV one. One of them is a live TV cluster. One of them is music. We have different levels of which we can hit, deciding on like how long your sample length is or how hard we want to go and search for things. There's a lot of logic goes inside there. But these guys can basically reorder and say, like, come and hit this cluster and this cluster first. If these guys according to this logic, don't get a good result, now go and hit this one. Again, if it doesn't work, go and hit these guys. Again, like I said, all driven through configuration. Now, the existing tests we had for this all were still driven through HTTP. Now, we had this nice Gwen library, so we're driving our stuff through there, but still every single request is coming through HTTP. We've got fake servers spun up here for taking all the requests. It's really actually crap, because what we cared about was logic inside here. And for those who are aware of ports and adapters architecture or hexagonal architecture, which basically states is, talking to outside services, they're ports outside of my system. I don't need to know how it's implemented. I just need to know it's a port. We follow that architecture already. So this is a port outside of our system. This is a port into our system. Inside here, we don't really know what's going on. So what we decided to do was push this to its extreme. So what we did was our acceptance test now drive our domain logic and our domain logic only. So it knows nothing about incoming HTTP request. It knows nothing about talking to HTTP. This, nicely, was already just a Java interface called cluster, I imagine, that you give it an object and it returns some objects. So we would just test our entire code through there. We integration test these points. So this point, we bootstrap Jersey still. We inject a mock which is basically replaces this part here. But we make sure we're just mapping our HTTP params correctly. We're making sure our providers are instantiated correctly. We're making sure the response code is the right response code and the JSON looks okay. But we do that essentially once. Again, on this side, we're making a remote HTTP call. So we spin up a fake server. And we actually go to that server, we check that we deserialize the object properly, we check that if we get an error code, we respond to an error code properly. But we do this once. And now the majority of our use cases actually hang around this area. And this brings our test run down from 9 seconds down to 200 milliseconds. And this is for each test case. And that's, in itself, that's a win. But a really strange thing came out of this. So what we're doing is, because our tests now take 200 milliseconds to run acceptance tests, we find we don't actually need to write as many unit tests. Don't get me wrong on this. Unit tests are still awesome, still very valuable, but we just didn't need as many of them anymore. So what we would do is we would write an acceptance test. And because we're following TDD, to its extreme, is we only implement any production logic if a test has made it come into being. So essentially, for the first acceptance test, we're not going to write any unit tests because it's pretty much a straight line through our system. The second acceptance test is going to bring out different bits of behavior. But we may or may not add unit tests at that level. It basically comes down to is, are acceptance tests covering this stuff enough or not? If they are, we're not going to repeat ourselves. So remember earlier I said I really hate duplication? If writing a unit test is basically just duplicating what the acceptance test does anyway, we're not going to bother write that stuff anymore. And I believe this was a lot of the crux of what DHH was getting at with his whole is TDD dead thing, is by focusing more on our acceptance tests, less on our unit tests, our ability to refactor a lot of code suddenly skyrocketed because we haven't got mocks everywhere. We haven't got these really strict contracts on our code. We can essentially throw a lot of it away and just start again because we've got all these acceptance tests that run really, really quickly. But again, don't throw your unit tests away. That would be bad. So we would have some logic that would, an acceptance test would basically exercise maybe 2 variations or something. But ultimately, there could be 5. We're not going to write a whole bunch of acceptance tests for that. We'll write the 2 acceptance tests, and then we'll use unit tests to drive out the other bits of behavior at that point. And another interesting thing that came out of this was we realized our system's actually split into 4. So we've got configuration. So in fact, no, not that diagram. Here, we've got configuration. We've got bootstrapping, which is essentially, it's Spring. Spring's launching the Jersey stuff and doing our DI. We've got infrastructure, which is HTTP here. It's Jersey here. It's Dynamo, SQS, remote servers. And then we've got our domain logic. And the problem with testing our systems fully end-to-end is it's really easy to let your business logic slip into any part of that system. And I'm sure everyone's seen this is you let business logic slip into your JSPs. Like, we actually had business logic in our Spring configuration. Like, an example was we moved at some point from CPU to GPU based clusters. But before we were prepared to release that on the public, we wanted to make sure it was going to produce the same level of matching. So we brought a whole bunch of GPU clusters online, but we could configure our system to say, hit this cluster, but don't ever send the results back to the user. Now that is business logic. But when we came to rewriting this stuff, what we found is this was Spring configuration. So Spring was just wiring in a different bean depending on what that flag said. That was actually a bad thing to do. So the crux of that is basically, if your acceptance tests drive your business logic alone and don't do any of this stuff, your ability to let your logic slip into the layers that you really know you shouldn't, but you do, that goes away. So one final point on this. So right at the beginning I said I was rewriting our search system. So I did. That was Java, JaxRS, Jersey, and Solar. Recently, for reasons I'm not going into, I've been rewriting it again. But this time I'm using Scala and Elasticsearch, and Scalatra is my web framework. And this is essentially what my stack looks like for this. I have a tiny bit of dependency injection, no Spring. I have a tiny bit of configuration. I have HTTP, Scalatra, domain logic, my search client, and I have Elasticsearch. But what this illustrates is you can't always test all of your business logic purely within the JVM, just in your own code. So doing a search is, Elasticsearch does a lot of the heavy lifting for me. So my acceptance tests, they still bypass DI, they bypass configuration and HTTP and Scalatra. They invoke the domain logic directly, but I cannot get away from using an Elasticsearch instance on this, because what I'm looking for is quality of results. And a lot of that is basically how I build my indexes and how I build my search queries. Now, I don't want to basically mock out the Elasticsearch and say, am I sending the right queries to you? Because that's basically, it's the same as mocking JDBC. All I'm doing is verifying my assumptions, and I never want to just do that. I actually want to go to the real service and check a round trip. So I can actually show you some of these tests if I can find them. So just ignore all of that. Acceptance tests, that's the one. So this is a complete change here. Sorry, just ignore my errors down there. So this is a complete change, as I'm using Specs 2 now for this rather than JUnit as well. So what I do here is, and this is one of the really nice things about using Scala and Specs, is I can write a really nice DSL. So I can say, having this track by this artist, and list the whole of them available to search. So this was doing what my previous stuff was saying, given the search service has this available. This does this here, but in a really readable way. I'm aware it's probably not as awesome as it could be, but I've only been doing Scala a few months. If anybody watching this thinks they know how to do this better, feel free to get in touch and give me some help. So this does my system setup. Now I do is I run a test, and I say I'm searching for the artist and for X. Must have tracks with the artist and for X. So you can see is that was actually a simple test and not very useful. Oh, this one's much better. So here I'm searching for tracks with running, must have tracks with the title running. So I think I've got an artist called running. This is the bit I didn't prepare very well. at all.
Can you make that text a tiny bit bigger, Colin? It's hard to see from the side.
Sorry? Oh, so you need bigger?
Yeah, that's it. Perfect.
Let me just get rid of that sidebar. There we go. Okay, so here I'm going to search for the artist Iron, and I must have tracks with the artist Iron Maiden. So here's an example of these are the only 3 results I should return. But had I got things wrong, and actually I did, so I wrote these tests, it may have also returned these 2 results as well. Now, mocking out Elasticsearch here, or the Elasticsearch client, wouldn't necessarily give me the information I want. I do want to round trip the entire thing and make sure that when I execute the queries, it actually comes back and gives me all the data that I need. Now I've made it big enough, that's essentially all I have to show there. So to summarize on this is end-to-end testing can be problematic. I think everyone's aware of that. But focusing on our business logic lowers our feedback time completely. Write integration tests for your system boundaries, but that's the only time you want to use those system boundaries. Drop them immediately. Identify what your ports and adapters are outside the system, and let your actual acceptance tests inform you of what those ports and adapters want to be. And the final thing is, what works for me may not work for you. So you just kind of want to find your own way. And if you think I'm doing something stupid, please let me know, because I always like to hear that. And I think that's it for the presentation. Over to you, Simon.
Okay, sorry, I was.
You were taking a nap.
I was trying to find the window. I was trying to find the window so I could unmute myself. But cool. Okay. So any questions that we've got? I've pinged people in IRC. Any questions? Please throw it straight into IRC. So Colin, how long has this kind of journey been? Really, that you know, this isn't kind of an overnight journey, right? Where you just go click your fingers and then everything works. How long did it kind of take you from going to that original stage where you realised, okay, shit, we've got all these problems, all this JSON or whatever, and it needs to change and something smarter, to actually working in a perhaps existing day where everything's nice and smooth, getting rid of all that technical debt and legacy and all that?
So far it's been about 4 years. A lot of these issues, and it's kind of the reason why I put this together in the first place, is a lot of these issues don't become apparent straight away. So the stuff about like accessing URLs and doing JSON is that actually took a real long time to realize that was a problem, because it's just, you know, you're just plowing away, and I think I wrote like 50 to 60 acceptance tests, and the API never changed, so it all looked really, really good. But then it's a few months down the road, and you make a change, and now it's like, oh, you know, fuck, I've got to go make all these changes. Now, what's the easiest thing to do there? I'll pop in and make those changes really quickly, because now I just want to get my feature delivered out and done now. And then you do the same thing over and over again. So, like, all these things is they take time before you realize that it's such a big problem you need to change the way. And to be fair, we've still got some of our systems use that original formats. Like I said, we're not retrofitting this stuff, but they are typically services that I think they've just been deployed for years, and we never change them anymore. They just get their job done. And I would say the journey is still not over.
Yeah. It's one of those where the journey's just ongoing, right?
Yeah. Oh, especially now I've started using Scala as well, because that brings in a whole new area of things for me to play with.
Cool. So no one's asking questions, which is unusual. So it sounds like you might have got off easy, Colin. Any questions from you, Oliver?
Well, I mean, from the technical perspective, not exactly, but I guess I could ask a question that probably Shazam deals with on a business basis. I actually have both Shazam and I'm assuming your biggest competitor, SoundHound.
Yes.
Yeah.
Heard of them.
And I'm wondering, you know, I mean, for something that people probably wouldn't pay for, even though the technology blows my mind away really every time I have both installed on my phone. So, I
Hmm.
mean, how does and this might not even be a question that you even want to answer, Colin, but how do two companies like that coexist and continue to grow and kind of make money?
Oh, does Soundhound still grow? Oh, I thought we
I don't
destroyed them
think
now.
like you know more than I do. So
Well, interesting enough, we have just surpassed 100 million active users per month. Um, so the guys, obviously our users are really, really happy with it. I'm not really prepared to get in on air how we're generating revenue and funding things.
sure.
I may get told off for that one. But we do, I would say, we do make money. People love what we do. That's probably all I can say.
Okay.
But we have the better technology, and we are definitely the better company. And we're based in London, which is like the coolest place to be as well.
Okay, so we've got a tech question in from PB on RC.
Thank
What
God.
style of... Say again?
I said, thank God there's a tech question. I was like, so what kind of cookies do you like? Huh?
So this is from PB on RC. What Scala test tool do you use? Is it Scala test or check or something else? Did you have to mock any static methods? And is it even possible to do that considering Scala has no notion of static, so I guess with a companion class instead of static?
So I actually use Specs 2. Not really a good reason. I think first thing I picked up was Scalatra, was like my first real introduction to Scala. And they just examples using Specs 2. I picked it up, thought, yeah, and this seems quite nice. Dug some more into the frameworks, and this one works well for me. I'm not thinking it really matters which of those test frameworks you use, because you can do a lot of some of the benefits, like the example I showed with like just doing text-based stuff, that's just Scala constructs at the end of the day anyway. So it's the language that's giving you the flexibility. As for mocking, I did do some mocking. Let me just see if I can see where I did it. I don't do a lot of it anymore because I'm not a huge fan. Why did I do? Oh yeah, let me spec. Sorry, just bear with me. It's I'm not really sure where I've done this stuff now. Test. Oh yeah, so basically, so what I did there was essentially the same as the stuff I outlined. Is I'm integration testing the HTTP part, so just the Scalatra bit. So all my structures basically is here I've got my HTTP. Well, put mine smaller. Here I've got my HTTP bit, and here I've got my domain logic, which it just hands off to. So I've basically just mocked that part of the system and used Makito stuff that's built in with Specs 2. And that's actually really nice because the language there it's post-execution as well. So if anyone's used Spock, it's the same way that does it. I don't have to set them up as preconditions. I can just run the code and inspect the object afterwards. So my code basically just says there was one of my class dot method called with this value in. And as for statics, no, don't be doing that kind of stuff. In fact, just don't have static things in your code base at all, ever. It's bad.
Which is pretty much the reason why Scala pulled it out of the main classes and into companion classes, right?
Yeah, pretty much. I mean, it's going to be really bad saying this because I'm still writing my book on unit testing, but just try to do less unit testing, and all these problems disappear.
Excellent advice. So I guess read less about unit testing as well, right?
No. Read more about it.
Read more about it, write less. Cool.
Yes.
Okay, so no more questions at the moment, but one thing I do want to share. I'll share my screen. If you can see my screen now. If you click on watch sessions, past sessions, you can see that today's session is already up, even though we're still recording it. If you click on that, you can watch back the current session and add comments here if you wish, or the meetup site as well. So other than that, let me get rid of this recurring. I'm not sure if you can see me now. For some reason, my Hangout screen is a bit weird, so I'll push it back to Colin.
No, we can't see you. It's all good.
Excellent, that's perfect, even better. So yeah, a really big thank you to Colin for joining us on the VJug. Yeah, cheers, buddy. And,
I hope at least somebody found it useful, if not interesting.
Oh, absolutely, and we'll push this through the community after today as well. You can follow Colin on Twitter. Colin is at TDBMonkey. And I'll throw that into the IRC and other places as well, so you can just click on that link and follow it. So, Colin, thank you again, and thanks, Oliver. And for now, we shall see you on the next VJug session. Cheers, guys.
Thank you. Bye-bye.